The coronavirus pandemic has spread across the entire globe, has infected more than 10 million people, and has killed almost half a million people. Wouldn't it be nice to be able to make small changes to our lifestyle and stop the virus in its tracks? Finding such a solution, however, requires understanding of a fundamental property of all viruses. A virus can replicate only inside the living cells of an organism. This need of a living host cell leads to an effective strategy in slowing a viral epidemic's spread. Just prevent the virus from finding new people to infect. Physical distancing goes a long way in preventing COVID 19 infections. The CDC recommends keeping at least 6 feet away from others. But how exactly are we implementing the 6 feet apart guideline? Even though we have progressed so much technologically, we content ourselves by just putting up signs. But can't we do better than that? This is the question that got us thinking. How can we use our knowledge of wireless localization and wireless sensing to create a device that can remind us of physical distancing? A device that can warn us if we are venturing too close to others. Out of these thoughts was born this 6 feet apart wearable gadget. It constantly scans the area around itself using wireless beacons, and if another similar device is spotted, it communicates with that device to determine the distance between them. An audio visual alarm warns the users of close proximity. Imagine such devices being present on every shopping cart at a grocery store. The card then will warn you if you get too close to other shoppers. In a hospital, the 6 feet apart gadget can be worn by doctors and nurses, maybe clipped onto their ID cards. Teams will have their gadgets pre programmed to ignore proximity of team members. But if another doctor or nurse comes close by, the 6 feet apart gadget can beep to warn of potential cross contamination.
The core idea of 6 feet apart is wireless distance estimation. If we can somehow measure the time of the flight that the wireless signal takes to travel from a transmitter to the receiver, then by multiplying this time to the speed, we can get the distance. The wireless signal travels at the speed of the light, which is 3 into 10 raised to 8 meters per second, which means that it is so difficult to measure the time precisely. 6 feet apart uses wireless radios called ultra-wideband or UWB with 1 GHz bandwidths and precise clocks which have a precision about 1 feet. So it becomes possible to differentiate between the direct line of sight passes and the reflections from the nearby objects, enhancing the robustness of our system.
When many devices are in the vicinity, measuring distance between every device pair causes significant message collisions. Our broadcasting protocol reduces collisions and improves estimation frequency. We must ignore instances when there is a wall between devices while not confusing blockage due to a person's body with that due to a wall. Fortunately, UWB signals can capture subtle differences in channel impulse response to classify an observation as line of sight, human occlusion, or physical barriers. Using a simple classifier ensures that it can run even on small embedded devices. Our prototype will soon be packaged and ready for the real world. We hope to see you soon at a grocery store near you. Please practice physical distancing and stay safe.